From the ocean's depth to the tip of our fingers, the tale of internet connectivity across countries is no longer behind the shades. Whether you're lying in Asia or flying in Europe, your data stays with you no matter how far the distance is. But have you ever wondered how the internet made its way across the vast and treacherous seas? In this video, we'll show you inside how this idea about spreading the internet reveals and how the submarine cable actually helps execute this innovation. How was the idea made public? People think data is in the cloud, but it's not. It's in the ocean. This revolutionizing statement was said by Jane Stowell while overseeing Google's submarine cable project. For a long time, our people have perceived that all the data is carried out through vast satellites beyond the Earth, but it's no longer the complete fact. Yes, satellites are still internet connectivity operation, but now 99% of international internet traffic is delivered through huge undersea cables lying at the ocean's depth. Merely 1% of internet data is transferred through spacecraft. From one point to hundreds of thousands of miles to another, there are now stacks of submarine cables connecting the world with the fastest digital data units. But this idea wasn't popular before, like today. It was mid of the 1800s when the first transatlantic telegraph cables were laid to connect North America and Europe. Cyrus Westfield was the person who paved the way for fastest internet connectivity across the oceans. His launch of this technology has undergone many setbacks and failures, but finally he was able to showcase his talent. However, due to large financial, logistical and technical problems, he couldn't give his transatlantic cable the recognition it deserved. It was under operation for a month and was declared highly prone to get damaged by sea storms and all the natural disasters that would affect communication. After his unsuccessful attempt, several other companies came up to lay their cables under the oceans. Now the cable lines were modified and had proper water coverage not to get damaged by the sea storm, fishing ships and whales. In the early 1900s, submarine cable connections became a new norm and the government agreed to fund a project to facilitate faster communication between different parts of the world. Eventually, Morse codes used to make calls abroad were updated with technology and calls could be made longer, but the connection needed to be upgraded at the time, so the capacity was below average. Finally, in 1980, fiber optics were introduced that don't require waiting in a queue for long hauls just for the sake of one call. The first submarine fiber optic cable was laid in 1988, connecting the United States and France, known as TAT-8. This cable could transmit data at 40 gigabits per second, much greater than previous copper cables used for undersea communications. Fiber optic technology was getting widespread for internet connectivity when researchers observed it could transmit data at high speeds with minimal signal degradation. This actually opened the way for more advanced developments of commercial undersea fiber optic cables for internet connectivity, with the first transatlantic fiber optic cable for this purpose being laid in 1998. Since then, the era of advancing internet connectivity across the oceans has begun, and it's in full swing today. It has opened the way for more advanced cable development that can withstand natural marine environments and improve cost-effectiveness to a greater extent. How are the submarine cables set up in ocean? The process of laying the cables under the oceans still needs to be automated and requires a large number of skilled workforce. The more the procedure looks complex, the more special care it requires, as mishandling can badly disrupt the entire interconnectivity. However, cables laying vessels are ships specializing in connecting the world by installing submarine cables under the oceans. They come with upgraded equipment for laying the seabed's wires, including cable handling machinery, cable plows, and remotely operated vehicles. However, a professional workforce ensures that installing the fiber optics wire will carry out safely and effectively. The laborers first survey the entire ocean floor to get the best low-resistance route. They analyze the water depths of the ocean floor to lay the cable that's robust enough to tolerate the water pressure, check seabed conditions to avoid rocky areas, to bury the fiber cable successfully, and all the important factors that can interrupt the internet connections. After completing the survey, the cable-laying vessel ships are sent to bury the line inside the seabeds. The team checked if the area had no uneven surface, as it could drastically damage the wires. Also, the cable should be buried enough to avoid damage, but not so deep that it becomes difficult to access for maintenance. Entire undersea cable network with land-based infrastructure to enable data transfer. They connect the cables to internet stations located on the seashore with access to territorial networking stations in different local areas. However, the shores where the cable's tension is situated should be monitored carefully. it shouldn't be too loose so that the passing of vessels couldn't damage it, or if the wire is tight, it will break under pressure. The workforces later sent the entire fiber cable network into rigorous testing to ensure it works correctly. What if the cable network gets damaged? There are 1.4 million cables under the ocean currently in operation. These large numbers of internet wires stretch up to 1.2 million kilometers from Earth to the Moon by crossing the sea. Now, can you say it's impossible to note damage? Certainly no. Technical faults are the most unpredictable fact that can occur at any time. Among all the countries, 2 faults are reported in a week. The most common reason behind the destruction is natural marine disasters, such as earthquakes, tsunamis, and severe weather conditions like hurricanes and typhoons. In these cases, the chances of getting damaged are higher if the wires aren't adequately covered. Secondly, sport fishing ships that mercilessly throw out their sharp nets to catch the fish are another significant cause why the frequent damage of cables is reported. Also, these cables' optic networks require occasional maintenance, as continuous exposure to salt water and other environmental factors can weaken cables and make them more susceptible to damage. However, sometimes big sea animals like blue whales and sharks may be attracted to the electromagnetic fields generated by the cables. This also causes massive destruction inside the oceans. When such cases happen, the internet company sends a professional team that typically includes trained engineers and technicians with equipment. The crew locates the fault by sending electrical signals, and later repair ships are dispatched to the site to begin the repair work. Nevertheless, it's worth noticing that the entire world connectivity is unaffected whenever destruction occurs. When one wire breaks, the other will pick up the traffic and reroute it, so the browser hardly catches any difference in the speed. But sometimes destruction covers the entire country. In 2013, a fault in an undersea cable connecting Indonesia and Singapore caused internet disruptions for several days, affecting millions of internet users in the region. Similarly, in 2011, the wires inside the Persian Gulf got damaged, disrupting the internet connectivity for several countries, including Qatar, Bahrain, and the United Arab Emirates. The future threats. The undersea internet connectivity seems strong enough to go for centuries, but no, they don't have the potential to go against future threats. Firstly, the SLRI model has predicted that the global seawater will rise significantly over the coming decades. It's likely to go beyond 0.3 meters by 2030 and a further rise of 1.5 meters by 2100. All this scenario is mainly due to greenhouse gas emissions due to the increase in melting of glaciers and ice sheets. The more ice melting occurs, the more water flows into the oceans, causing the seawater to rise above the level. Furthermore, cybercriminals are now targeting the undersea network. Hackers could attempt to disrupt internet connectivity by targeting undersea cables or the data centers that process internet traffic. But it doesn't mean that internet providers can't control these hazards. The companies can relocate the cables and shift them to safer spots where the chances of getting exposed to crimes are lesser. Also, the facility providers can opt for more satellite services, as controlling the rising sea level is difficult. Satellites will work like another route to pick up the data traffic. Elon Musk's company SpaceX has already started working on such a project and striving to promote their satellite internet infrastructure in low Earth orbits, but it's still in the planning phase. However, hardening the fiber wires, conduits, and other infrastructure can also be more beneficial to resist climate change and has a lesser impact on connectivity. Despite the future threats, the underwater internet connection across the continent is also prone to the environment. While the placement of cables in the oceans, digging trenches in the seafloor, and using equipment like plows to bury the cables disrupt the seabed, which impacts the marine habitat to a great extent. Also, the optical cables contain chemicals that are harmful to the environment, and if any mishap happens, it can lead to the release of chemicals or oils that can pollute the surrounding waters. Everything aside, doing maintenance with heavy equipment and precisely when cable-laying vessels ship operations cause greater physical damage to the sea animals inside the ocean, which is unbearable at any cost. So that's all about how the internet spreads across the globe through oceans. If you like the video, make sure to subscribe to our channel and let us know what you think about shifting of the internet from sea to satellites.